Hello, I'm Egypt.
Hi, I'm WVU.
And together we are NCIS, two idiots on one keyboard.
Absolutely.
So this talk is intended to be Bash basics and basically accelerating hacking through Bash. We originally submitted this as a DEF CON 101 talk, but they put us in this room, and it's a little bigger than I was expecting. So we're going to be switching back and forth between slides and a shell to demo as much of this as possible. I hope that goes okay. We've tested it, but DEF CON. This isn't Linux system administration, but there's a bit of overlap there. Like, Linux system administrators have to use Bash a lot, so a lot of what we're going to be talking about fits in that same realm. Many of the things that we're going to show you are things that you would use as an administrator, but a lot of them are also going to be things that only hackers would really care about. So we'll get that when we get there. But we're definitely not going to be reading the man page because...
You can read it yourself.
Yeah. And man bash is cavernous. I don't know how many of you have ever opened that up, but it's bloody enormous. There's an awful lot of stuff in there, and we're going to try to highlight some of the things that we think are most important and the things that we use all the time. But we're glossing over a lot. There's much in man bash that I've never even read. So take what we're saying with a grain of salt in that respect. But there are resources to help. Man bash isn't the only place where you can learn about using bash. One of my favorites is explainshell.com. And I want to see a show of hands. Does anybody know what that incantation is? That little bit of arcane stuff. Okay, so a few of you know what it is, a few of you don't. This is a fork bomb. It's making a function called colon that calls itself repeatedly in the background, piping to itself, and then runs it. So this will just spin out of control, making as many processes as your system will allow. If you don't have a ulimit set, that means all of them. But explain shell shows you what's happening in this command line. So you can see here it says this is making a shell function, this is a compound command, this is a pipe, this is ampersand, which puts the whole thing in the background. So explain shell is a great way to take a command line that you either don't understand or want to more fully understand, plop it into explain shell, and it'll give you a breakdown of how the whole thing works.
And before you try, it actually just parses it. It doesn't actually run the code. So no RC there, hopefully.
We tried. So in the abstract, I wrote this little piece of stuff here that sometimes you just need to pull out the third column of a CSV file. And this is less true as of a couple of days ago when Bloodhound switched to JSON. But a lot of what we do as hackers is parsing stuff output from one tool to get it into the right format so that other tools can use it. So this sort of manipulation is very common in dealing with all the various kinds of tools that we use. So it gets weird sometimes with like randomly cased stuff, and for some reason some of them are quoted, some of them are not. So dealing with the weird output on a command line is sometimes tricky. So we're going to just step through some of our solutions to do exactly what this abstract thing said. So one thing that a lot of people do, and I'm a big proponent of, is the up, edit, enter, repeat loop. So you start on the command line, you type out, oh, I'm interested, what does this file contain? So I'll head this file, or I'll cat this file. Then I'll pipe that to grep, to pull out just the stuff I'm interested in. Then I'll pipe that to cut to get just the sub string that I'm interested in. All of those steps can be done with one awk command line because awk is very powerful. Awk is a full programming language, and we'll talk more about awk in a minute. But there are a bunch of people who will tell you that this is specifically a useless use of cat. Those people are jerks. Don't listen to them.
It's normal and okay.
Hack however you want to hack.
So there are a few different conventions that we'll have here. Usually stuff in man section 1 will be your normal system utilities and tools. So most of the stuff we'll talk about will be in there. If you ever want to know, man, and it will show you all the sections for the various man pages. There's some overlap, obviously, with syscalls, which is section 2, C functions, section 3, and config files and other stuff, section 5.
And man-k will also help you search through which section you're actually interested in.
One does not simply, this is a Unix system, I know this. Meme the memes.
So these are the basic things that we're going to cover today, beginning with pipes and redirection. We'll step through each of these individually. We'll look at them on a command line and see typing how they work. Pipes and redirection are probably one of the most fundamental things that you'll use all the time. Variables and substitution are useful in a lot of cases. Many times you can get away with not using variables at all. We'll talk about a bunch of the standard tools, the various kinds of expansions you can do, and then we'll go through some examples at the end. Because you can't just say everything is a file. Please. It's a file. No, it's a file.
All right, to the terminal.
Here we go. There we go. So everyone's familiar with echo. That puts stuff on standard out. Cat takes stuff on standard in. So we can echo what? Pipe to cat. Most of these spaces are superfluous. So you can say echo what? Pipe cat. That's fine. This again is a useless use of cat. We can, yes, hack how you want. The angle bracket operator redirects to a file. So you can say echo what, redirect to a file called what. Then we can cat what. That's actually not a useless use of cat. But interestingly, that doesn't have to be at the end of the line. You see it most of the time it's going to be at the end of the line, but it doesn't have to be. You can say what, echo what. That totally works. You can do the same thing with input as well. So you can say what, cat. Also totally works. I find that useful when I'm doing something where I want to edit the end of the line a lot.
Like grep.
Exactly like grep. So you're taking a bunch of stuff in and you want to read the same file a lot of times, hit up, enter, up, edit some stuff, enter. Having the file at the beginning of the line means you don't have to use your arrow keys to go through and deal with all of that. There's also this magical command called exec, which doesn't actually do anything except for the file descriptor redirections if you don't give it a command. So you can say like exec.
Yeah, don't actually run that unless it's in a subshell here, because we'll lose that window.
Yeah, I'm not going to run it.
The redirections.
It's okay if you do something like this. We'll talk about devs TCP in a minute. But what exec does here is it's making a new file descriptor called number3. It's opening it for input and output, and it opens the file. We could do that. It doesn't have to be dev TCP. This could be what right here. And now I can say cat and 3. Excuse me, Cat.
Yeah, so normally the exec will replace a process image, but you can use it to set up arbitrary redirections like here.
So that's fun. It gets especially fun later on when we deal with dev TCP, but you'll see that later. Right there. There's an example of it, but we'll talk about it more later. Oh, I did the same thing I told you not to do. There we go. I'm sorry about built-ins?
Yeah, so built-ins are built into the shell. They're not actually commands in your path, like, cat, set, grep, whatnot. If you can use them, it's a little more performant because it's not actually shelling out to a different process. It's all built within the shell, and you can do quite a lot with that. Looping, echoing, checking conditions.
So grep is the standard thing for searching stuff. If you're coming from the Windows world, this is sort of similar to Findstir. Findstir is kind of... I'm trying to come up with a nice way to say this. No, it's just not good. That's... So if you're not familiar with regular expressions, like these three little things here are probably going to get a major portion of what you actually want to do with regular expressions. So the dot star means dot, match any character. Star means any number of times, 0 or more. And that is a whole lot of what you want to do with grep most of the time. The caret anchors at the beginning of a line, so make sure the match is at the beginning, or dollar match at the end. And those three things are most of what you need for an awful lot of most people's grep usage. And if you're not familiar with regular expressions, this is a great way to get started. Just use it a little bit and read more when you need more. A wise man once told me that the best way to get good at programming is to read a little, or read a lot, write a little, repeat. And it's been my mantra for years that if you read a lot and you write a little and then you start over and do it again, you will improve.
It's all in the practice.
And sed is an editor. It's a stream editor. That's what the name means. So it does a lot more than just substituting. This is the sort of thing that everybody uses sed for. If you've seen someone use sed, this is probably what they did with it. The S command does a substitution. So in this case, we're taking a file called foo. We're changing all of the instances of foo inside that command, or inside that file, and we're changing them to bar. In this particular command line, we're also deleting the first line. The reason you might want to do that is cutting off a header. So that's the primary usage that I get out of sed is cutting off headers with 1D or ND, any number D will delete that many lines, and substitution like that. Sed does a lot more than this, but this is most of what you need to get started. You can also separate stuff inside quoted string if you pass the whole thing as an argument. So I guess I should talk about quotes, huh?
Yeah.
On a bash command line, quotes make things one argument. So at the lower level, there's a command, or there's a function called execv or execve that takes the binary you want to run. In this case, it's sed, and then each of the arguments that gets sent to it. In this first example here, this is one argument, and this is one argument, and this is one argument, and the spaces are what separate them. The shell decides where that happens.
It's called word splitting.
With quoting, this is one argument. The spaces don't separate things because the quotes make the spaces not special.
And it also has the effect of escaping any special characters like semicolon, which would normally separate commands out.
Right. So we've got our what file here. We can pipe that to sed. We changed what into lol.
Use of cat.
And that's a useless use of cat. Because we exactly the same way like this.
Or without redirection at the end. Yeah, sed's picky.
Okay. So that was fun. Sed also has this -i thing to change it in place. It's not exactly in place. It's kind of in place.
And that argument's different between operating systems, so be careful how you use it. Some will ask you to specify more arguments. This example here actually deletes from a log file that IP address. Any lines containing that IP address, it just deletes it in place. Might be useful.
And ed is the standard editor. Wait, I have to go. Ed is the standard editor. If you read man ed, it says that it's the standard editor.
And that's a running joke.
And
it's the standard editor.
It's the standard editor. Okay. Do you want to talk about cut?
Yeah, cut. So we'll cover awk in a bit here, but cut can do field separation. You can pull out fields from a string or a file, strings within a file. So you can specify a separator, -d. It's a delimiter. In this case, it's comma. If you're doing CSV or anything like that, that's quite common. And you can select on certain fields, like 1 to 3, so that's fields 1 through 3, and then also 5. Now, the problem is that the delimiter is usually a single character, so if you have arbitrary white space, it's not going to work so well, which is why awk might be the superior solution. Yay.
One thing to note is that cut can't reorder anything.
Yeah, it's basically left to right.
Yeah. And sort stuff. That's what it does. Says it right there on the tin. But it has this awesome flag -u, which uniques stuff. So it will only give you lines that are unique among the file, so you don't get multiples. So if something contains 2 copies of the same address, then you will only see one of them. And cat concatenates stuff. Hack how you want. Unique is very often taking the input from sort. So it's really common for people to say sort pipe unique. Most of the time you don't need to do that because sort has -u. So unique is pretty useless unless you want to count stuff. And unique -c lets you count the number of multiples. So sort will give you everything in a sorted order, -u will remove the multiples, or pipe to unique -c, and then you get a count of how many exist in the file. So oh, hang on.
Yeah.
Now we don't have the header.
You can use head for that too.
Yep. And then these are all unique, so it doesn't matter.
It would work in theory.
I tested this when I was sober. That was supposed to have that right there. Awk is a language. It's so much more than just printing a single file or a single field from a file. But most of the time, that's really all you need. It's a replacement for cut in a lot of ways. And I personally never use cut because I usually have to reach for awk afterwards anyway. And then I just have to rewrite my cut line So I might as well just start with awk.
And if it looks like Perl, that's because awk preceded Perl and basically defined all of this text processing stuff.
Yeah. And there's a lot more to awk. Awk, GNU awk in particular, has a full TCP stack. So you can write a full reverse shell payload in just awk, which...
Terrifying.
Yeah. Variables? Don't mind me editing as we go. Variables. Variables are good. So what's happening here is we say foo equals echo what? That's process substitution happening there. We're making a subshell.
Command substitution.
I'm sorry, command substitution. Not the same thing.
And we'll cover that later.
Yep. So now we have a variable called foo because echo what, echoed the what, and then the whole thing here is the value of foo. So this is exactly equal to foo equals what. If we said foo equals echo what, then we could just say $foo, and it runs the command, which is important. If you accidentally put something blank, so say you have two variables, we have another one called bar, and it's empty, say bar foo, it runs the second one. Be careful. Be very careful.
Yeah, this is how people have been writing shell scripts, especially stuff that is privileged.
There was an especially fun bug with, was it Steam a few years ago? I think it was Steam, where there was a script that did something like...
Oh, yeah. I think it was a Linux Steam client, and they forgot to quote something, and...
It was something like that.
Yeah, don't actually run
But foo was empty.
You know, you should be protected against this on most modern systems, but don't try your luck.
What I actually don't use enough is variable substitution, where you can take a piece of a variable and run various kinds of transforms on it. A lot of what I use sed for can be done if you already have the text in a variable, just with variable substitution. So this here takes foo and sets it to my current path with colons replaced with spaces. So echo path has all of that stuff, and echo foo has the same stuff, but all the colons are replaced with spaces.
Useful if you wanted to iterate through that as a list, perhaps, with loops later.
So we'll talk about loops in a second. There's a special variable in Bash called IFS, and we'll talk more about it in a moment. But IFS is the input field separator. It's mostly spaces.
There's usually three. I think it's tab, space, new line, something like that.
Yep.
I might be missing one.
It's fun with a post-exploitation to be able to run commands for situations where you can't use spaces for whatever reason. So say you have a command injection vulnerability in a web page, but they're stripping spaces out. If you replace it with $ifs, then still works. So it's fine. I use history expansion all the time. You probably saw some earlier when I was just noodling around on the shell. But bang bang is your whole previous line. And you'll see that it gets echoed here as well. So this is my whole line. This echo comes from here, and this is the result. But there are other special things that you can get from history here. So let's start with no, those need to be spaces, pardon me. Bang colon 2 is the second argument. You can do that with any n. I find this super useful for a lot of things. The one I use probably almost as often is bang star, which is all the arguments. Oops. Bang dollar is the last argument. Bang caret is the first argument.
And the neat thing is that instead of bang dollar, you can actually, there are a bunch of read line keyboard shortcuts you can use. If you hit like alt period, for instance, right there, it'll drop that last argument right in there, and it can cycle it too. So if you really need to tab something in quickly and drop the last argument, that's what you'd use.
Bang -2 is the second command in your history.
Previously.
You can also do arrange. And history expansion actually expands, so when it goes into your history, you get the result rather than the bang substitution. Etc. All of this is controlled by your /dot input RC, which is your readline configuration file. This is my input RC. So a lot of the things that you're seeing me do on the command line here are a result of this input RC configuration. Magic space means that when I do a substitution and hit the space bar, it actually replaces it in my current command line. Super useful for speeding up all kinds of substitutions. It makes it so that your history is no longer a thing that you operate on as itself, but as part of your working command line in your up, edit, enter loop. History search backwards. A lot of people use the Control-R key for that, and it's really useful when you do it that way. But I've also set it to the up arrow. So if I say, I don't have an awk. I have a, what do I have? A sed. So if I type SED and then the up arrow, it gets the last command in my history that began with sed. So it does a reverse search just with the up arrow. This is such a huge time saver that it'll change your life. Make this change and thank me later.
And definitely check out more of Readline. It's a library that handles this line editing stuff. You can do, there are tons of key bindings, like Control P, which is right close to your home row, is actually up arrow.
Ugh. Oh my God, so many things. There we go. Braces.
Oh, so brace expansion, we haven't talked about yet, but it is related to the IFS stuff. We'll cover that later, but it allows you to take a list of strings or whatnot and expand them out. Normally, people have used seq, S-E-Q, historically. It'll print out ranges. You can do seq 1 to 10, and it'll print out 1 to 10. But brace expansion is built right into the shell. It's basically like a built-in in the shell grammar. So you can do lists like this very, very quickly. And it takes steps too, so you can jump to. zero padding, a bunch of different things. Really useful in scripts, or if you wanted to grab a bunch of numbered files, for instance.
Tilde expansion is kind of similar to variable substitution in that it happens when the command is read, not when it is run. So that changes the meaning of some things. There was some confusion about this when I tweeted about it a few days ago. Tilde plus is your current working directory. Tilde minus is your old working directory.
And notice those are absolute paths.
This is tilde plus is different from dot because it happens on the command line before the command gets run. This is really important for scripts that change their directory before they look at their arguments. So if you, in particular, Eyewitness on Kali, I'm looking at you. Not that I'm going to name any names, but Eyewitness on Kali, I'm looking at you. It changes its working directory before it looks at its arguments. So if you say, Eyewitness foo or -x foo.xml, it'll be looking in its installation directory for foo.xml. It won't be able to find it, and it'll complain. But if you put tilde plus, then it works. It doesn't work if you say // because the dot is just a literal dot.
You can kind of think of it as the difference between dot having special meaning to the program, or sorry, to the program. It's a relative path actually, and whereas a tilde expander, tilde plus here expands that out and actually interprets it.
So loops are a really useful programming concept, but they end up being pretty useful for dealing with all kinds of weird data too. So I mentioned earlier that you can read in a file at the beginning. This is exactly where I use it all the time. While read is fantastic for dealing with lines of a file one at a time. This $reply here is the default variable that while read will pull in, or that read in particular pulls in. You can also give it a name, but note that it's while read a name. It's not a dollar name, because that actually expands it first, and it's not what you want. Don't do that. I use for loops a lot, specifically for dealing with lots of files that I want to change. So this line inside here can actually all be done with brace expansion, which I do all the time too. So you say move foo.1.text to, I want it to be a CSV, so I'll say CSV. What's happening here is it's replacing this with this on another argument. So if I put it here, you can see that it gets both arguments there. And if I do it with move, now I ls foo star, and foo.1 is now a CSV. But that doesn't work when you want to do lots of them. So command, the foo, or the for loop, lets you do all of that in a loop.
Oh, we already did
used
that.
the wrong, yeah, shut up.
There's also a rename command, a couple different ones that can do this, but remembering the syntax is a little bit harder.
Yeah, and rename is super unportable. Sometimes it's a Perl version, sometimes it's the GNU version, and they take completely different arguments and have completely different semantics. So just use a loop. It's easier.
Because Unix.
Because Unix. Process command substitutions.
Yeah, this was a fun one. Now I get the keyboard. So we talked a little bit about command substitution and process substitution, but mostly in passing with the previous slides, or text file.
Slide-ish.
Clear the screen here. So command substitution is a way of substituting a command as text. And process substitution is a way of substituting a command as a file. So text, you could do echo. I'm going to quote all my variables and command substitutions. Echo what? Is that what I write? Yeah. So it basically echoes what, substitutes it as text, and then passes it to echo. So it's just echoing what. You could also do cat.
Useless use of echo?
Sure. Well, we didn't cover that one. But process substitution has this syntax here, and now this will try to echo what as a file, and it will try to cat that out to set it out. And it takes actually a couple different directions. Command substitution above is quite simplistic. Anytime you want to replace some command, some complex command, and shove into another command as a text field, that's what you want. But proc sub is a little bit more nuanced. We can see here. So it's actually a symbolic link to a pipe. And a pipe, I have to remember Control B, I'm using your setup. A pipe is write on one end, read on another, but you can notice the permissions are different here. So the left pointy bracket for process substitution substitutes in a file, but it's for reading only. And you can see that right here, the R. And the other one, which is a write, that's permission there. So you can only do it in one direction. So confuse those at your peril. Usually commands that take in an input file, you could take another command and substitute it in as a proc sub, and you've basically read a command as a file. For others, command that takes a write. You could write to do some stuff, and you're basically writing to another process through a pipe. So pretty useful for complex command lines.
I use diff. I use this for diff a lot. So you can say like,
there's a good one.
Diff foo sort foo, something like that. So it's making a sorted version of foo and then telling me what's different about the file on disk. You can alias stuff, so things that you type a lot, you don't have to type quite so much. This is one of my favorites, L dot. Shows you only things that begin with dot, so it shows you hidden files. It's kind of handy. You can alias anything, including substitutions, and they will happen at the time that you run it, which is handy sometimes.
For more complex things, you can write a shell function, but we don't really cover that here. It's in the man page.
Okay. So now we're going to mostly switch back to why are these still in here? Skip, skip, skip. There we go. Aliases are good. Examples. So I used to use this big long command line with sort. What is that? K4 column something? I don't know.
Oh, it's for the key def.
Key. That's right.
Key.
Yeah, but there's actually a GNU version of sort that just takes -v and it does
now
the right
in
thing.
BSD and OS X.
Yay! Sort --debug is actually really cool for viewing how it decides that stuff is equal or not. And so it gets like a little underscore below the pieces that it sees as comparable.
And that's
so
the GNU version uses underscore. The others have some arcane output, so good luck.
This I really like this small little awk one-liner. I actually have this as an alias now because it's neat. But it lets you print only unique lines without having to sort, and sometimes that's important. Basically what's happening here is awk has an array called scene with keys being the whole line, and if it's been seen before it'll be 0 because it hasn't been set. And after that increment line, it'll be a non-zero value, and it won't get printed. It's kind of neat.
we're not going to run this stuff because networking is hard. But there's some remote stuff you can do with SSH. I'm sure most of you already know this. Maybe, maybe not. -J is an option for proxy jump, I believe, which was added semi-recently in SSH. So if you ever use like proxy command or whatever and fed netcat to it, you can basically obsolete that and just jump through another SSH host as a proxy using just -J. And you shove that in your config if you'd like. Different things, and most of you have used D, that's a SOCKS proxy, starts a SOCKS 5 proxy locally. You can change the bind port and all that. So you can feed other tools through it, through your SSH tunnel. You got local and reverse forwards, of course. Local, it binds locally here. What you're doing is you're basically forwarding 3389, which I think is RDP, you open a port locally and it forwards it through user at host 1 to desktop 1 3389. So you can connect using our desktop localhost 3389. It will go through that jump host and then to desktop 1.
What's fun is chaining these. So you can say SSH-J to a host, and then on that host you say SSH-J to another host. And then on that host you say SSH-L, you listen locally, it tunnels through all of them, and then it's like you're hacking in Hollywood and you got behind 7 proxies.
Speaking of that, shells, reverse tunnels, you can catch a shell remotely and have it forwarded through your tunnel down locally, which is real good for hiding where things come from, I guess, or bypassing restrictions between networks. And these two last examples are just kind of try to illustrate the redirections you can do. Normally SCP does this under the covers, but you could use T or cat and redirect input-output and read and write files remotely. And that is not a useless use of cat.
Bash can do a lot of really ridiculous things with TCP. So we mentioned this fake file dev TCP. It's not actually a file. It doesn't really exist. If you look on the file system, you won't find it. It's actually a special case inside Bash. In the C code for Bash, there's a special case for a file called dev TCP, and it lets you just make arbitrary TCP connections. So yeah, explain your shitty port scanner.
Yeah, thanks. This shitty port scanner here, it uses your for loop, your brace expansion, a couple redirections, a couple command separators, and it's all in a loop. I guess I can just run it. Did I do that right? Control-B-O. Yay.
Yay.
I'm trying to remember it now.
I don't think we have enough time.
Yeah? All right. I'm not going to run it, but you should run that command. And it's using all built-ins.
Yeah, this is actually really fast. It's ridiculously fast for how simple it is. I use Excel-B all the time for copying files to the primary copy buffer in
clipboard selection for
it's clipboard selection.
You
it's
have
awesome.
all the selections.
Yeah. This pipe end here is a special syntax in Bash that lets you do both standard out and standard error piped to the same place. Also very useful. Now for the hacking. You dirty hackers.
Yeah, we'll probably have to run through this quickly here.
Yes. There are a lot of things that snitch on you if you're not careful. .bash history is a file that gets written with all of your commands that you run. So there are a couple of ways you can get around that. You can unset histfile, which is the variable that stores where that file gets written to.
Or put it to dev null.
Or you can set it to dev null. Or you can link the actual file to dev null, but don't ever do this because then there's a link there and the actual file gets blown away. And if someone opens up their shell and suddenly has no history forever,
they'll be sad.
They're going to be sad, and then they're going to start looking for you. So don't do that. Yeah, so these are other ways. You can read the slides online also. We're going to skip over this, but
different
STFU.
ways to hide your history and
different ways to
logs.
STFU. Yeah, the commands sometimes snitch on you as well. So SSH will use your current username to whatever you connect to, unless you explicitly tell it otherwise. Our desktop and X3 RDP do the same thing. FTP does, but it doesn't actually send it until you tell it to log in. There's a .NET RC that will allow you to store an anonymous one. You can do the same thing with aliases to say don't do that.
Oh, forgot about this one.
Yeah.
There's different
yeah.
ways to hide spaces. You can use brace expansion.
Yay! If you don't have LS, Echo Star works just as well. Find dot also works well. If you don't have cat, while read also works.
Or head with a really long number.
There are a ton of ways to read binary text or binary over a text-only link, and there are quite a few ways of writing binary over a text-only link. But all of those you can do with Metasploit for free.
Host some stuff.
You can host some stuff. You can
Shellcode.
convert shellcode to hex bytes. That's fun.
I wish I could show that, but we're out of time.
Yeah, we're out of time. Read these things; they're cool.
And come find us.
And come find us. And I don't have my useless use of cat. I gotta go find that.